Right, hello guys, and welcome back to another part of my analog DIY synthesizer basics tutorial part 10b. Now, what I'm going to quickly try and cover here is a very small kind of block diagram just to kind of deal with the main 7 components involved within this Arduino MIDI to CV gate circuit. So as you can see, we've got our MIDI in jack, our MIDI controller, we have an opto isolator stroke opto coupler, we've got our 12-bit DAC, we're going to have a voltage reference, our Arduino, and our laptop. Excuse the poor artwork, but it works, come on. Right, anyway, so I just kind of wanted to break, like I said, I needed to break this down into small parts because there's quite a few details to go into, and there's bits that I really don't want to miss out because it could end up giving you a headache if you're trying to build this. So this kind of comes across as clear as possible. So please try and make sure you watch through all the videos and take notes of all the part references I make as well, although I will at some point try and do a list. So here is our MIDI to CV gate circuit. The only 2 things we have missing is our USB in and our actual MIDI cable in for my MIDI controller. So don't watch that too tough anyway. Right, so basically what we do is we will take our MIDI in cable from our MIDI controller, so we MIDI in out, so that's our out, and then what happens next, we will go from that MIDI jack, we'll wire that into the opto coupler. So we transmit that signal to the opto coupler, and the opto coupler will be linked with the DAC. We'll link into the DAC, and the DAC will link somewhere along the line into the Arduino. Now, on our Arduino, we need to power the Arduino via USB. I think you can actually power this via an adapter, as long as you kind of don't go over certain voltages, which I can't exactly tell you what that is. So we'll go from our Arduino into that we say our laptop to power that from USB, but then we want to take our reference voltage out to go into our DAC. So we'll take the reference voltage out, which we can make it say 5 volts plus 5 volts reference voltage, and from our Arduino we're going to get a gate out, and when I say gate out, we're going to get a gate pulse. I'll show you that in a minute. So we're going to need a multimeter to try and trace it. If we look at an Arduino, they've got quite universal pin configuration, but they do vary from model to model, as we can see. So from this particular one, I think if we go something like, I think we take the gate output comes from one of these digital pins here. It's either 7 or 10. I'll have to set this up again because it's a long time since I've set this up. I've probably got this noted down somewhere, and we'll sort of kind of run that. I'll try and somehow do a live test on how that works and how we get the gate pulse out and how I kind of measured it. We can do this without a proper oscilloscope. You can use a PC scope, make up the cable like I showed you in one of the other tutorials, probe until you get that gate pulse. Anyway, so we got the DAC having the reference voltage, and out from our DAC is where we'll get our control voltage out. So if we have an overview, we can see how that all links in. It looks a bit complicated, but that's why I'm trying to break it down as much as I can, so you kind of have an understanding of how this works. The DAC and the Arduino will output one separate thing each. The DAC will do the CV out, the Arduino will be doing the gate out. So if I just flip this board over, so what we do is from the gate, what we're going to do is we're going to get some kind of gate voltage, and that's all going to depend on a component called time. So if we hit our key, we press our key, and this will be our on, I'll press on, and this will be our off. So that will all depend on how quickly you release the key. If we hold the key for longer, obviously we're going to have a longer gate pulse. And what that pulse kind of looks like is pretty much like an envelope generator pulse. It's not going to be straight lines. It's going to have quite a funny curve to it, to be honest with you. So it will be over a period of time, and then that will decay quite quickly. But that decay is not it's not the same as the one we set when we make our envelope generator, because what this will do, we will take this gate in and we take the gate out from the Arduino, and what I did is I set that into a diode first, and then we will go into our envelope generator gate in input, and that gate input will send that to our VCA, which will then sustain. We set the parameters by the controls. So when we hit that MIDI key, that was going to the Arduino, into the optocoupler, into the DAC, into the Arduino, out from the Arduino, into the envelope generator, into the VCA, which will give us the sound depending on how we have this set up. You need to be quite careful. I use this for protection because I destroyed about 2 other Arduinos in the process of experimenting. So there we have it. Try to keep it as short as I can. There'll be more tutorials to come, so keep your eyes open, subscribe, give me a like, and yeah, help support the channel. See you guys.